Hey everyone, today we're going to be looking at the exact values of certain trig ratios at also certain angles. So I've highlighted the angles 0, 3, 30, 45, 60, and 90 degrees. So we want to look at the exact values that certain trig ratios like sine and cosine and tangent give at those particular angles. And so we'll also remember that the sine is opposite over hypotenuse, the cosine is adjacent over hypotenuse, and the tangent is opposite over adjacent. Also, I've noted that for our purposes, in terms of calculation, the hypotenuse is going to have a length 1. That way, when we take opposite and divide it by hypotenuse, we're just dividing it by 1, and we kind of don't have to worry about it in that sense. So, let's talk about our first trig ratio. We're actually not going to start at 0. We're going to start at 30. So for 30 degrees, let's draw a right angle triangle. (30 degrees) with a hypotenuse length of 1. Okay, so from this, we could use our kind of math to solve for the opposite. So let's do that. Sine of 30 is equal to opposite over 1. So opposite over 1. So sine 30, and I guess then we would multiply by 1. So 1 sine 30, just sine 30. Our calculator will give us a value of 0.5 or a half. So I always like to double check, but we get 0.5 or 1 over 2. So here we can start to kind of fill in our triangle a little bit. So the opposite side is 1/2. Now this ratio kind of holds no matter what the side lengths are. So this is a bit of a review of the concept of sine being the opposite over the hypotenuse. The opposite is always half of what the hypotenuse length is. So if the hypotenuse length is 1, the opposite side length, or the rise in the triangle, is half of 1, which is a half. If the hypotenuse were to be 4, the side length here would be 2. It's always half, based on the angle of 30 degrees. So that's kind of our first thing. And once we have that, we can start to build a lot of the other side lengths through some algebra. So let's actually do cosine 30 and kind of figure out where we can get an exact value from that. Because if we throw cosine 30 into our calculator, we're going to get 0.866. It's not a very nice number, but it can be made to be a nice number. And that's by understanding that this is still a right angle triangle, and we can use Pythagorean theorem to actually solve for the adjacent, which we'll call A appropriately. So cosine 30 is this 0.866 number. We're actually use the Pythagorean theorem to solve that. So we'd have 1 squared subtract half squared is equal to a squared. So we'd have 1 squared subtract a quarter is equal to a squared. 1 squared is just 1, so we'll get rid of squared. So a squared is equal to 3 over 4. Okay, so we square root both sides, and we have the square root of 3 over the square root of 4. Square root of 4 is 2, so if a is equal to 2. Okay, so what's that mean? Well, that must be the 0.866. So root 3 divided by 2. That's our 0.866 number to the decimal exactly. So 0.866 is actually root 3 over 2. So that's our kind of exact value of the cosine of 30. Okay, well, what about tangent of 30? Well, that is opposite over adjacent. So we have 1/2 over root 3 over 2. So we have this particular ratio. Seems to be kind of complex, but we can remember if we're dividing by a fraction, all we have to do is rewrite this as multiplying by the flipped version. Cross out the 2's. We have 1 over root 3. We're not allowed to have that in the denominator, so we rationalize the denominator. We have root 3 over 3. So, in the end of everything, root 3 over 3 gives us this 0.577 number. That should also be the tan of 30, which it is exactly. So, this is our exact value for the tan of 30. So that gets 30 off our list. Now, maybe dreading that we have to do this 4 more times, but with some clever thinking, we can do this about once more. We can automatically do 60 because we just did 30, and the whole time we were doing 60 as well, because all the angles in a triangle have to add up to 180. So this angle here was 60 degrees. This is 60 degrees. So that means, well, let's fill in the root 3 over 2 here. That kind of means that, well, the sine of 60 is the opposite. So the sine of 60 is now root 3 over 2. And the cosine of 60 is adjacent to that, so that's 1/2. And then finally, tan of 60 is the flipped version of this. This is equivalent to that, so that'll be the one that I flip, so it's root 3. It's going to be like a 1.7-ish number. Tan 60, 1.73. That should be the square root of 3. So there's a lot of shortcuts we can take in terms of symmetry. So that's 30 degrees, 60 degrees, and before we get to 45, we'll cover 0 degrees and 90 degrees. You might say, well, I can't form a triangle if that's my angle. Okay, you're right. But can we still take the cosine and sine of 90 degrees? Well, if we continually kind of make a triangle with an angle that's smaller and smaller and smaller as it approaches 0 degrees, the hypotenuse actually just becomes the adjacent length. So the hypotenuse over 1 is actually this length here. This is equal to 1. And if we were thinking of a triangle like this that slowly decreased in angle, the thing that this kind of looks a lot like is the adjacent. And adjacent has to do with cosine. So it goes to show that our cosine of 0 degrees should be equal to 1. And our calculator will also confirm that. Therefore, our sine of 0, you may have guessed, but we'll kind of play the analogy again. The sine was always what was opposite to this angle here. So as that decreased, so did the length of the opposite side until the opposite side was no more. And so we have sine of 0 is 0. And the tangent of 0 should very simply be opposite over hypotenuse, or sorry, opposite over adjacent. So it's 0 over 1 is equal to 0. Okay, so 30's done, 60's done, 0's done. 90 we can do symmetrically to 0, just some of the things flip, because now instead of going across one length, we've gone up, we've risen one length. So therefore cosine of 90 degrees is equal to 0 now. Sine of 90 degrees is equal to 1. These two here just flip. And the tangent of 90 degrees is error. Can't do 1 divided by 0. Tan 90. Calculator doesn't like it. So it's kind of just a little bit of symmetry in algebra to get you through 30 and 60 and 90 and 0 and 45. Shall not take too much longer, too much more of your time. So let's draw a right angle triangle with 45 degrees and a unit length of 1. Well, if you think about what 45 degrees is as being directly in the middle of 0 and 90, kind of means you go over as much as you go up. So we can kind of see this as these two lengths should be the same. So we'll call this A and we'll call that A because they're equivalent, and we'll run through our Pythagorean theorem. 1 squared is equal to A squared plus A squared. And the variability to actually set them equal to each other and make them the same variable allows us to solve this without any other side lengths. Usually we need another one, but not in this case, because 1 should be equal to 2a squared. A squared is now equal to a half. We square root both sides. Square root of 1 is 1. Square root of 2 is root 2. People don't like that in the denominator, so I multiply by root 2 over 2. So therefore A is equal to root 2 over 2. And that should be our exact value for both of these. So what we can then say is that this is both sine 45 and cosine 45. And so they should come out to be the exact same answer, sine 45 and cosine 45. And lastly, your calculator most often does not give you the root 2 over 2 number, but you'll see that that's also the 0.707 that we are looking at when we get sine 45 and cosine 45. Tan 45, well, these are the same, so it's root 2 over 2 divided by root 2 over 2. That cancels because it's the same thing. So tan 45 is just equal to 1. And it's nice to have your calculator to confirm everything. The algebra can be a little bit tricky, so just keep that in mind. However, that should be everything you need to know for the exact values of some of the basic angles, which again were 0, 30, 60, 90, and lastly 45.